have to say I'm quite disappointed that they're not going to see my face. I had a haircut and everything. Cool. So today I'm going to talk to you guys about securing RabbitMQ using Vault. So just to kind of give a bit of context here. So we're living in a world where it's full of problems. Think about things like global warming, communication barriers, so things like Rosetta Stones are solving language barriers, access to banking, things like blockchain. Everywhere you go, there are problems, right? Which is kind of why we have jobs. Every time you write a piece of software, you're either trying to solve a problem or you're taking advantage of an opportunity, right? Once you start trying to solve these problems, these are real world problems, then you go into this realm of engineering problems, right? And this is where the HashiCorp stack comes in. The HashiCorp stack is predominantly there to solve developer problems so that developers can focus on solving real world problems with their code. So to paint this picture a bit more for you, I'm going to tell you a bit more of a personal story. Don't know if you guys recognize that guy. That's me. That's me when I was younger, right? So as you can tell, I look the same, probably a bit cuter now. The other thing that's the same about me back then as to now is I'm quite ambitious. And I was very ambitious back then, as I've been told. When I was crawling, I wanted to learn how to walk very quickly. So I did, as you can see. And then there was one day I went out with my parents and we came back from shopping and my dad's unloaded the car, my mum's opened the door and put me inside the house. And as she's turned her back to grab the shopping bags that my dad's unloaded, I saw this giant staircase and I said, I can do this. I can do this. So I began trying to climb. And unfortunately for me, I fell and I hit my head. So my parents rushed me to the hospital and the doctor checked me out and said, yep, everything is fine. So sigh of relief, okay? And if we fast forward a few years, my mum noticed something about me. Every time I answered the phone, no matter how awkward it was, I would always place the phone to my right ear. I would have something in my right hand, and then the phone would ring, and I would do something like this. And she questioned me. She said, why is it that you don't put the phone to your left ear if it's easier? And I said, Mum, because I can't hear in that ear. But obviously, I'm young. I don't know any better. I thought that it's normal for you to not hear in that ear. So she's panicked. So she calls the GP. We go and see the GP. I get referred to a specialist. And the specialist does some tests and confirms that I am, in fact, deaf in my left ear. Right? This is a true story, by the way. My wife is sat right there. She would tell you, anytime she's telling me off, pardon, and she'll conveniently find herself on my left side. Anyway, there's a point to this story here, is when we went to go and see the specialist was trying to solve a problem that we didn't even know that I had. And that's the story of software engineers all over the world. They are solving problems that people don't even know that they have. Or sometimes they have problems and they don't even realize they have them. And Vault is a prime example of that. A lot of software engineers out there, before we started moving to the cloud, were quite happy to put passwords in plain text as long as it was behind a secure barrier. They didn't realize that secrets management was a massive problem for them. So with that context, let me introduce myself. So I'm Rob. I go by the alias of DevOps Rob. I'm an independent consultant. I work with a string of clients, and my goal is to help them extract maximum value from the cloud using HashiCorp stack tools. And I've been working with HashiCorp tools for, I don't know, maybe about 3-4 years now. So it's predominantly what I use to solve problems these days. So we just run through this agenda a bit quickly. So it's going to be a bit of a 101 talk, this. I'm aware there's a lot of people here that don't know what Vault is or don't know what RabbitMQ is or message queues. So if you do know these things, please bear with us. This is HashiCorp. We are a family. We leave no one behind. So we're going to go through the basics, and then we'll finish up with a demo of us refactoring some code to securely access RabbitMQ. Is that all right with everyone? Come on, a bit more, please. Yeah. Awesome. Right, so we'll start with Vault 101. So Vault is a secrets management platform. But what does that mean? I think to really uncover that, if we just define what a secret is, it's probably a good start. So I thought, okay, we all know what a secret is, but what's the actual dictionary definition of a secret? So I looked it up on Oxford Dictionary, and it says a secret is something that is not known or seen, or meant to be known or seen by others, right? So let's relate that back to the real world. Your bank card PIN number, pretty sure you don't want anyone to know that. Your Facebook password, your gym locker code. These are all real world examples of what secrets are. But if we translate that into the software engineering world, we have things like database passwords, API tokens, TLS certificates, and login credentials for third-party services. This is just a short list. The list is a lot more exhaustive than that, but you get the picture. We need a way to manage these things. There's another term that comes up when we talk about Vault, which is a secret sprawl. So again, I thought to myself, let's actually Google what that means, because though we think we know what it means, let's just be sure we understand it. Right? So I went ahead and I Googled, and this is what came up. So what is secret sprawl? My first answer to that is, well, it must be a term that HashiCorp came up with, because if you Google it, all you will find is HashiCorp content or blog articles from individual contributors talking about HashiCorp products. So I'd say shout out to the SEO team at HashiCorp, because they've got that term on Smash at the moment, right? No, but when we talk about secret sprawl, I'll build another picture for you. So I lifted this picture from the internet. It's just some PHP code, it's only 19 lines. And this is where the problem starts. It starts like this. Now, obviously, whoever's posted this has omitted the password for its publicity on the internet. But a lot of the times you will see a password inside code. And that's okay for 19 lines, but then you know how it goes with applications. It starts with 19, goes to 100 lines, then you've got 1,000 lines, then 10,000 lines. And in that code base, you will have multiple connections to different databases, to different service bus queues, to different services, just for it to perform its primary function. So if you get caught in a situation where you need to rotate those passwords, or you need to understand what is accessing what, how do you go about doing that? That's the idea of secret sprawl. So some people I know out there have tried to tackle this problem. They've done things like this. They've written their own password generators. They think they're solving a problem. But in fact, what happens is someone somewhere needs to know what that password is, and they need to record it somewhere. So they end up doing something like this. Is that familiar to anyone? I see a few heads nodding. Secret sprawl goes beyond code. As you can see, it goes on Post-it notes, it goes on whiteboards, it goes to wiki pages as well. It's anywhere that you've posted a secret. So with that, we'll look at how Vault can solve that problem for you. And the way we'll look at it is just the components that make up Vault. So we have a Vault server. And these are the main components. So we'll start with the authentication method. So what I mean by authentication is it's your way of proving to Vault that you are who you say you are, right? So if we go back to the bank card, every time you go to the ATM, you put in your PIN number. It's in the acronym, PIN, Personal Identification Number. It's the way the bank knows it's you, right? So Vault is quite flexible, it's pluggable. You can put different authentication methods in, depends on what your identity provider is. These are just some examples here. If you use an Okta, for example, if it's mainly services like containers, you could use Kubernetes, or maybe you want to use your GitHub. You have all your developers in GitHub and you just want to take those identities and import that into Vault. That's perfectly fine. We also have Active Directory is a good identity provider you can plug into that as well. The point is you can add one or as many of these as you want. We'll then move on to the next thing. So that's covered authentication. The next piece is authorization, right? So the difference between authentication and authorization is, like we said, authentication is about proving your identity. Authorization is about checking whether the person should be able to access a specific resource. So it's all about matching an entity to a rule that says, yes, they can access this, or no, they can't. So we'll go back to the bank card. So you've now put in your PIN number. The bank will have a policy that says, don't let this person withdraw more money than's in their bank account. They're not authorized to do that. I mean, I know we're pretty disappointed by that policy, but this is the way it goes, right? So Vault does this by policies. You can write very easy to read, human readable policy documents, and you can use that to control what entities have access to what secrets. We get to the next phase, which is probably what this talk is mainly going to be centered around, which is secrets engines. So you have a static secret, for example. Let's just say you're using a third-party service, you have a login. In Vault, you can place that static secret in there, and anytime someone wants to access it, if the policies allow them to, they can pull that. And that's really cool. But the thing with secrets engines is it introduces a new dynamic that helps us a lot. And this dynamic is the ephemeral secrets. To me, it's absolutely mind-blowing the way that you can use these things. What I mean by that is, if we take AWS, for example, if you use the AWS secrets engine and you need to access AWS, you can say to Vault, hey, I need to access AWS. Can you give me a set of credentials? And what Vault will go and do, it will go and create you a user, give you a username and password, which is short-lived. So let's just say 30 minutes, for example. And at the end of that 30 minutes, that user will be removed from AWS, and you don't have to worry about secrets being sprawled all over the place. It's completely taken care of for you. And that's the real magic for me of Vault. There are so many different secrets engines out there. And if one doesn't exist for your service, as long as it has an API, you could write your own secrets engine for it. It's completely pluggable. And the final thing is audit devices. Now, you have to excuse the singular file icon I have there. I couldn't find any good icons for the other audit devices. But what an audit device is, every single request and response in Vault is logged. An audit device allows you to place that log on, in this example, a file. So it could be an audit.log file. But you have two other methods as well, which I haven't detailed here, which is syslog, and you have Unix socket as well. So the idea with that is these are security logs. Your security team, you should be able to push these logs to some kind of central, I don't know, Splunk or something like that. And your security team should be able to look at these logs and ascertain if something dodgy is going on. If someone is accessing something they shouldn't be accessing or attempting to, it will show up in that, and then they can take action. So is everyone good with Vault? You understand what Vault is? Seriously? Good. Right. Now, we'll go to message queues. So RabbitMQ is a message queue platform, but that probably doesn't mean anything to a lot of people that have never heard of it before. So what is a message queue? It's a mechanism that allows microservices to communicate with each other, right? So again, if you've never heard of the term microservices, let's paint the picture for you. So you have an application. An application can be made up of multiple services. The idea of microservices is it decouples these functions, if you like, from each other, so they can run as completely independent services, which don't have any reliance on another service particularly being up. It's always going to run, and they can consume each other as required for the application to work. So the problem here is, as you can see, we have 6 microservices here. If service 1 needs to talk to service 4, it needs to send a message there, how is it going to do it? And this is where message use comes in and solves that problem for us. So the first concept I'll introduce you to is message producers and message consumers. So a message producer it's in the name. They produce a message, right? A consumer consumes that message. But still, if you look at this picture, you can't quite see how that problem is solved. The next 2 things that I'll introduce you to is the exchange and the queues itself. So what's happening here is service 1 is a message producer. It produces a message and pushes it to a message exchange. Now, all a message exchange is a message router. So it will route the message to the correct queue. So in this example, it could be message queue 1. And then once it hits message queue 1, service 4 can pick up that message from there and do whatever it is that that service is supposed to be doing with it. So it's quite simple. Now, we're going to do a bit of a live demo, but just to kind of paint the picture of how the demo is going to work, we'll probably just use something like service 1. We'll use the exchange and message queue 1 and service 4. The rest of it, we don't need that. This is just to kind of depict how it would work, right? So in the demo, we're using Nomad. Originally, when I wrote this, I did a Docker Compose file, which is fine. But as soon as I got invited to do this at HashiTalks, I thought, well, let's use Nomad, just in case no one's ever heard of Nomad. It's something that's going to stick with them, and they can go off and Google it, right? But this is perfectly fine to do in Docker Compose. So we use that. Nomad is just a workload scheduler. So if we look at something like Kubernetes, Kubernetes is responsible for scheduling container workloads. Nomad does the same thing, but it goes a bit further than that. You can schedule binaries, you can schedule batch jobs. It's a lot more flexible than Kubernetes and a lot simpler. We'll also use Docker. So we'll run RabbitMQ in a Docker container, and Nomad will schedule that for us. We use RabbitMQ, obviously. We can't not use that. And this is all about vaults. We'll use Vault. So what I have is, I have a couple of microservices that are written in Go, which are just going to basically perform these functions. And just to configure everything, we're going to be using some bash, right? So with that, I will flip over to the demo. Awesome. I need to mirror my screen because I don't want to get a bad neck. Fabulous. Okay, so in this demo, the first thing we need to do, I said we were going to use Nomad. So first thing we want to do is start Nomad. So we just run this command. Fat fingers. The really cool thing about HashiCorp products is you can start it in dev mode for situations like this where you're just doing a demo. You don't want to go through the whole circus of setting up clusters properly. So as you can see, we have some logs here. So Nomad is up. And if we just open this up, let's just show you what the UI looks like. Okay, so we have a UI there. There's no jobs running it. So how Nomad schedules its workloads is it has this concept of a job, right? So if we just take a look at a job file, so the first one we'll get up is Vault. So anyone that's used any of the HashiCorp tools before will know that HCO is the proprietary language that we use. It's a DSL. Nomad is no different. You can describe your job. So here we just have a data center. So it's kind of like a logical group of servers, I guess. I'm just running this on my laptop, so it's just DC1. And every job has a group. Now, the main thing I want to point you to is your task drivers. So like I said, you can schedule so many different things. Here, I'm using something called raw exec. It's probably not the best way to do it in production. Oh, by the way, that's a caveat. There are some things here you're going to see that you probably shouldn't do in production. So don't go to your boss and say, Rob said you can do it like this. No, we're just having some fun. This is HashiTalks. But we have raw exec. Now, there's a lot of documentation as to why that's probably not the best one to use, but I'll leave that to you. And all we're doing is we're scheduling this binary, which I've given it a URL, and it's literally going to go off, fetch that URL, fetch the binary from that URL, and it's going to run it for us, right? So let's do that. Cool. So we will do Nomad job run HCO. Okay. So let's schedule a job. And if we look here at the UI, we will see in a moment that that will kick in. Awesome, it's kicked in. So let's verify that. So we're running it at localhost. And it comes up, right? by the way, some house rules here. Anytime I do something in this demo and it works, you need to clap. We have demo gods. They're watching us. Thank you. Right. So next thing we want to do is we now need to get RabbitMQ up and running. So similar concept. This one is using a different driver. It's using the Docker driver. So it's just using the underlying container engine. And just like you would configure your Docker container to run anywhere, you have the same parameters here. So it's quite straightforward, anyone that's used Docker before. So we'll do the same thing. And we see it's there, right? Almost. Almost. Let's be sure that it's really working first, right? So what we'll do, again, we'll go to localhost. And the port is 15672, I believe it is. Now you can clap. Awesome. So we have Nomad running. It's scheduled our Vault workload, and it's scheduled our RabbitMQ. So next thing we want to do is let's just quickly log into Vault and have a quick look at it. Now, if we go back to the job file for Vault, you will see that this is a demo. So again, you wouldn't do this in production, but to make my life easier, I've set this environment variable, which sets the root token for us. Obviously, you wouldn't use Vault in dev mode anyway. So that's how I'm going to log into Vault. So I'll type in DevOps Rob. Oh, fat fingers again. Demo gods, please. Hey, thank you. Thank you. I'll clap for you when it's your turn, I promise. Right, okay, so very straightforward at the moment. We haven't really got much going on. So the next thing we want to do is we want to now configure Vault to be able to access RabbitMQ and be able to create dynamic credentials for us, right? So to do that, we have a short bash script and a few JSON files. So if we just quickly look at the bash script, everything in Vault you can do via an API, which makes your life so much easier. So we're just going to make an API call, and all that's doing is it's creating the RabbitMQ secret engine there, and then it configures from that secret engine the connectivity to RabbitMQ, and it creates a role which kind of defines the parameters of what kind of credentials Vault will be able to create in RabbitMQ. So if we just have a quick look at some of these JSON files, it's quite straightforward. We have the connection string, and we have the username and password. Again, you wouldn't do this in production. You wouldn't have this in code in a GitHub, but this is a demo, right? The next one here, it's just configuring the engine. So we're saying that in this one, anytime it creates a credential, the credential can be valid for 60 seconds. Now, you probably wouldn't do that in production, but I've done it because I want to show you how it cleans up after itself. And I don't think you fancy sitting here for 5 minutes in silence waiting for it to happen. But the maximum it can do is 120 seconds, right? And here is the permissions, if you like, that the dynamic credentials will have. So it's the vhost that it can access, and it's got write permissions and all sorts of other RabbitMQ things. So it's quite straightforward there. So what we will do is we will run that bash script. Demo gods, please. Okay, no errors. Oh, sounds good. Let's verify that. We have RabbitMQ there, right? So you can clap. Thank you, thank you. Right, let's open up another terminal. Let's test that. So, like I said, everything you can do in Vault, you can do via an API call, right? So we'll just do a quick curl. So in the header, we're just going to put the token, which is DevOps Rob. And the endpoint is HTTP 127.0.0.1/v1 / we know this because of the way we've configured it. So everything in Vault is path based, right? So all we're doing is we're calling a path, right? So, oh, I am. Thank you very much. That's the demo god that spoke right there. Who was that? Hand up. Please give this man a round of applause. V1. So we're going to read the creds, and the role that we're going to read is Rabbit role, because that's what I called it. Now, just to make that look nice. Oh, VI, thank you. See, the demo gods. This is why you have to clap, you know. Thank you very much. So this should work, right? We're in this together, right? Look at that. Awesome. Yes, thank you. Now, I don't have long, so let's quickly see if we can log in with that. Was that the password? And we'll copy this. Quick, 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 quick. Oh, ooh. Maybe it's expired. Okay. Don't worry about that. That's probably expired anyway. Don't worry about that. It's fine. If we just log in as guest again, because that's what you do when you're in trouble. You go in as root, right? And okay, I probably didn't paste it properly, but as you can see, this is the user that was created. 1419. Well, sorry, 1419. 1419. So it created a user, right? Cool. So if we go to our code, this is just a very simple Go application. All it does is create a channel, an exchange. It creates a queue and posts a message to a queue, right? The important thing I'm drawing your attention to here is this connection string here. So as you can see, we have the username and password in our source code, right? So let's run it. As producer. Okay, so if we do go run main, okay. Cool. Okay. And if we just set up a consumer, so let's have a quick look at the pre-consumer. So again, all this is doing is it is going to consume a message that was posted from there, right? So and we'll run this, go run, and I'll go. And that's listening, so just run this one more time. And a message is received, right? As you can see, you can clap. I was nervous as hell when I ran that. I didn't think it was going to work, but hey, right. Okay, so how can we refactor this code? So if we look at, once we add Vault into the mix, what we will do, so actually if I put it side by side, maybe you can see it a bit better, right? Sorry, I can't hear you back there. Oh, okay. Let's see. Thank you very much. Oh, maybe too much. That'll do it. Is that better for everyone? Awesome. Okay, cool. So which one is this one? This is... All right, thank you. So if we look at the, that's the pre-consumer here, and then here we have the post-consumer. The main difference is we're importing a couple more packages. So we're importing mainly the HashiCorp Vault API package and the OS package as well. And the reason why we're doing that is I've done it so that you can set environment variables to set your token rather than having to put that in your code. Yep, sweet. Well, I've been told I've got to hurry this up, so I don't have time to walk you through this code. I'm quite happy to talk it through afterwards. So what I'm going to do is I'm just going to go off and run this code. Okay, sorry, I didn't realize it had gone over so much. Okay, apologize. I will do this online or something sometime. Thank you very much.